Okay, thank you. Welcome. So this talk is based on a story of a ship. This was a small ship in the ocean. So, and I know the story of the ship, and I will conclude some very general thoughts. So it's okay if you don't agree. And the ship is called Robots, and we are a company that works on sales automatization. I'm happy to be a data scientist on the ship, and we are mainly a Python house. It means I think 98% of our code is written in Python. We've got 30 developers, more or less the same number of microservices, I think. And yeah, so this talk will be about microservices mostly, and also about the tools we use to make microservices more effective in our setting. And why I think there will be a long introduction about microservices, because there is a lot of talks on the web on microservices, but mostly in big companies. There are some different problems in big companies, and there are some other problems in small companies. For example, in big companies you can afford to have like infrastructure team that will carry over some tools and others, while in a small company you have to do everything on your own. Okay, and I choose the team for the presentation, and so the team actually has got some example photos, and one of the photos are the wind turbines, and so I just left them here because I think it's a good metaphor of a microservices world. Like before, we had big power plants, coal or nuclear. It took time to build them, and they were huge. They were for years, and now we move to wind turbines, and you can have two of them, add another one next year. They can work separately. You can have a farm together, and so on and so on. So that's like the picture of microservices when you move from monolith, the old coal power plant, to microservices, wind turbines. And so how was it at our company? So I'm a data scientist, so there will be some graphs and charts today. So that's the chart of an enthusiasm to microservices in our company over time. So as you can see, our company is 2 years old, almost. So we started to build a system based on microservices more or less a year ago. And that's how it starts. So at the beginning, you watch the videos, you read blog posts, your enthusiasm grows. Then you start writing code. It doesn't grow so fast anymore. And then you try to deploy the microservices, and then it falls. Then you deploy it to production. It falls again. You got first serious outage. Then you get used to the serious outages you have, although everyone told you that in microservices world, the system never falls completely. Yeah, if it's designed very well, that's probably true. But at the beginning, one microservice falls, and then all your system is down. You will see. So now we are somewhere, I think, it's already October, so I think we are getting up on this enthusiasm curve. It's because we are at the point where we realize that our progress wouldn't be possible if we didn't switch to microservices a year ago. And when we add new features, you can't even think of other way of adding new features than just adding a microservice for a bunch of them. Okay, so some definitions, concepts. It's a bit hard to define microservices, but usually you say it's a way of building systems, and in this way, in all systems over the years, you had to divide your system into microservices. So you needed the components to manage the code, the infrastructure, the complexity. And in microservices, the components are just the microservices. That's the way how you divide your systems. And because of this, you've got the microservices are different applications working in isolation. There's another important term, isolation. And this is what gives you much. Like you can upgrade the microservices separately, you can deploy them easily, you are not bound to technology, you can have multiple platforms. Yeah, you hope to have partial outage versus total app failure. At the same time, you've got distributed data. You've got, I would say, more democracy, because microservices impose not only the change of the way you build a system, but also you have to change the way you build your teams. And microservices, it's also connected to the fact that you try to build products, not projects. So a team builds a product, it's a small part of the whole product you sell, but the team is focused on a product, not a project. Okay, so I get all these terms. I still miss one term. So I didn't say anything about the micro prefix. So that's what Martin Fowler says. He's a guru of microservices. So he said, so micro means the microservice should fit into my head. But you see, it's not a very good definition, because we've got guys in the company that keep in their head all the legacy systems we have, but no one else does. There is also the concept that a microservice has a single responsibility. That's also hard sometimes, because you can say that payment is a single responsibility, and you know that in a big company, payments can be huge. For example, in a bank. And there is also another concept. So you say microservice is when one team can manage a few of them. Yeah, so that's not a definition of micro in the services world, but it's more like to give you some overview of how big the microservice should be. Okay, and another chart, actually similar chart was one of the presentations of Zalando, and actually we observed the same. So over time, you start with microservices, and you've got some fixed number, and then people just keep adding, and there is more and more of them. So on the left, it's log scale. So it's like, at our company, a year ago, we had around 5 of them. Till January, we still had 5, maybe 6, 7. Now we've got 30. That's the growth we will have if you do the microservices, and it's a good thing. It means that you are good at the single responsibility, the dividing into smaller chunks. Okay, so there is another thing that you have to keep in mind, because you need to know that microservices won't solve all the problems with your legacy app. And sometimes they will even make them bigger. Because, for example, intra-microservices changes are really hard. So before you start, you should make sure you have provisioning of machines, because when a team tries to deploy something, it needs to test the system, so it's very, you can work faster if you have the provisioning in the cloud. you need to make sure you've got good monitoring. And what I mean by this, if there is a problem in your system and you start to watch into the logs of a single microservices, it's often the case that it's very hard to get to the root cause of the problem. You need to have monitoring of business transactions between microservices to know what was the problem. You need to think of deployment of your application, and you need to have something like DevOps culture. So every team, even a team which is directly product team, not connected to infrastructure, must have some basic skills to deploy his service. Okay, and that's how we come to the API first concept. So that's the basic concept when you start writing a new microservices with defining an API. And that's why do you do this? It makes it a waste of time, but what we observe is that it's a very good specification for an API definition, very good specification of business needs. It is good at limiting scope of a service. It gives you, the scope is connected to isolation, so you got better isolation. And when I think on writing API first, it's quite similar to writing tests first. So at the beginning you make some rough specification and then you try to implement it. It's the same with API first. So it really works. And there are various tools to write your API. One of them is Swagger, which is now rebranded to OpenAPI. There are tons of others. Swagger is one of them, and I will focus on Swagger in this presentation. So Swagger is focused on REST APIs that are JSON APIs. It is defined in YAML or JSON. And it's good because it's quite, the tools around it are open. And there is a lot of tools for Swagger in different languages. Okay, so how does the Swagger API look like? So we've got some headers. We've got a pet store that has a base path API. That's basically working on JSON data. So it's got under paths one endpoint, pets, and then you've got you can call get on it. You give an ID and you get the pet amount. Yeah, quite simple. It also specifies the response type. So response type is here, and response type references the definition of a pet. And what is pet is actually up there. So pet has basically ID and name, and sometimes also a tag. Okay, is it clear till now? Okay. Okay, so this was a simple world when you just started with a single microservice, but in real world it doesn't work like this. Because that's why comes the ship in the storm. Because you never start just building small microservices, you usually start with a big system with lots of dependencies, and you try to divide it into microservices. So you have to handle the legacy code and build microservices at the same time. You also usually work in fast-changing environment like we do, so the business requirements change quite fast. You have services that are too big, so it's not that easy to create API and Swagger for them. Sometimes the API can be specified because the service responses with either this or that, and only some person in your company knows what actually the service responds with. Sometimes you get a big service that lacks an API, and then you, for example, like we did, so we tried to generate Swagger API automatically. There are some tools that basically analyze the communication between systems, and they can produce you Swagger API automatically. We tried this, we spent 2 weeks trying to make these APIs, and it took maybe another 2 weeks when we tried to update these huge APIs that had about 1,000 lines. We failed it. Yes, why the API is forgotten is also often the fact that you make quick fixes, and then you forgot to change the API. Yeah? That's like the problem of documentation, that it's always behind, and the more it is behind, the harder it is to go back on track. So actually, so there are problems we have, and like one of the big problems here is that we treat the API as a documentation, and actually it's something more than documentation. And if you treat it just like a documentation, it's often useless very fast. Okay, so we've got the microservices word, and now what can we do to prevent the API to be forgotten? Another chart. This is a number of changes for microservice API that is drawn against the size of the microservice, and by size I mean the number of endpoints. So it's not an official data, it's more like my intuition from experience. So actually what it says is basically if your microservice has 1, 2, 3 or 4 endpoints, you won't have to change it very often. But then when the size of microservice grows, you realize that you change it all the time. So because of the problems with too big microservices, you have too much changes. Yeah. Okay, so hopefully there are some tools in Python that can help you writing the microservices in a good way, and that can help you keep the API not forgotten. The picture is a big barrier, so it's the old style, right? Not microservices, but a big water power plant that takes 20 years to build. Okay, so there is a number of tools in Python environment for Swagger. So first of this is Flask RESTful Swagger. So what it basically does, so you get your Flask server, you can annotate the endpoints of the server with a Swagger definition that is bound to an endpoint. It's quite nice. So just to get the path, you need to have the definition that was before in the YAML file presented to you. Now you just annotate it with something like documentation. Yeah. So we have the same information here, that we've got an ID parameter to be got called. The parameter is in path, it's of integer type, and the response you get is pet resource, and there is an example even, and when you implement the endpoint you got, you pass the ID and you return the pet model. So, and you have to define the pet model. So the pet model is actually what we had before as a definition in the Swagger file. Yeah, so a pet has ID, name, type, optional. Okay, apart from that, you still need to create a wrapper of a Flask API. So that's you create API of a Flask app. You specify where the Swagger file is stored, and you have to add each of the resources manually. Yeah, last line. Yeah, so that's the code to make the get endpoint in our pet store using fast RESTful Swagger. So it's quite nice because it gives you models validation. The Swagger file is generated automatically. So if you run the server, you can go to API/Swagger.json and you can have the Swagger file for all the endpoints. So it's very nice when you can explore. If you have, like we do, 30 microservices, and you can just go to the server service and hit API, Swagger.json, and see what's inside. It's nice because the way you define the resources here is very resource-oriented. So in pure JSON REST specification, you have main endpoints that are resources, and you've got the basic parameters like get, post, delete, and so on. And this way is very nice at in encoding this resource-based REST APIs. It's not that nice, I mean fast RESTful Swagger, if you don't have your endpoints very resource connected. As you've seen, there is probably some boilerplate here, and the fact that the specification is spread between the endpoints makes it a bit hard to read. And if you design the API first, and then you have to divide the APIs in Swagger into several places where you put the definitions. Not that nice, right? You don't have the overview of a whole microservice. Okay, and so we've got some server. There is another problem with clients. So what you usually do is at the beginning, you've got no clients. By a client, I mean a bunch of classes in Python that you talk to a microservice. So for example, we've got a quite big microservice that is called user management, and more or less half of other microservices speak to user management. That's quite obviously, for example, post session ID, and then they get some user data. So you don't have like dedicated clients to microservice, to user management, and then you see that, hey, all of our microservices share the code to connect to user management. And you've got the code duplicated. When you change the user management API, you need to change all these clients. So from no clients, you think, okay, so it would be nice if we have the client to a microservice stored in the same repo where we have the microservice itself, right? So you think, okay, so we can have then we can test whether the client matches the API that microservices make, and you can have a dependency. Other microservices can depend on this library, and that may look nice. But then you realize there is a problem of dependencies. So for example, some payment system depends on user management library, client library, right? That's quite hard, because then yeah, you've got multiple dependencies inside your code. So when you update the library, you have to make sure all the clients have pulled the new library. So then you may also then think it may be and there is another problem. Then when you separate the library, you've got dependencies between the library, that is a client to user management, and the user management itself. the microservice. Okay, and then you think, and actually the client and the microservice itself, they share some parts of code. For example, user models. So what you think, okay, so let's make another library that will have models that are used by both client and a microservice. Okay, so you put the models in another sub-project, whatever, library, and then you realize that for each microservice, you've got at least two libraries. Usually you've got some code to run the microservice itself, another project. You often have a microservice that is spread into a few modules. So for example, we've got a lot of salary workers inside microservice. So now you realize that your single microservice is not micro anymore. And then you've got another bright idea, because it's not simple, so you think, oh, maybe we can make a library that will have all the clients to all the microservices we have in our company. And that's actually a terrible idea, because then all the other microservices depend on this common library. Yeah, you've got a common library pattern that is used everywhere, and you never know if you change something, what gets broken. Okay, so it's probable that you end up in the black hole after this step, but sometimes you are happy to survive and go back to your clients. And then you start to think of, why did we enter the loop? And what I think, actually, it's because we didn't treat API specified in Swagger file as a first-class citizen and the main source of proof. Because every time we wanted to have API here and build a client in code here. So there is a solution for that, and you can generate a client. So you've got an easy way to generate a client. That's going to be a tough part, but I will try to do it. Okay, so I've got Swagger UI. Hope you can see it a bit. So that's the definition you know. That's an online editor for Swagger. And I've got here on the right nice overview of what does it mean, this API. I can get some description that is here in the API, so that's quite nice, right? Okay, let's generate a client for this. The list is quite big, which is Python. It generates the client, and hopefully I can open it. Oh, it's here. So, whoa, you look at it, it's a code generated for my small API with pet store, one get endpoint. So I get the whole library, that's nice. Okay, well, to start, I try to see the code. So there is some common code generated for API client, quite general. Okay, there is nothing for my ID, for my case. Where is the pet store? There are some models, still nothing. Models, oh, here. Oh, okay, now I've got a model of a pet, which is what I had in this. That's nice. There is something like a default API. Whoa. I'm trying to find my get call, but it's not that easy. As you can see, that's the way you can go, but you don't think your code is more simple after this step. So let's get back and try other tools. And one of the tools I found is Bravado, designed by Yo, I think, or it's just a fork by Yo. And that's basically, if you think the code generation is awful, especially in Python, which is dynamic. So all you have to do here is to have an URL where your Swagger file JSON is exposed. I assumed it's exposed in our domain. Yeah? So then you create just the client for this URL, and then you can see that I have a client, I had a pets endpoint in the Swagger API, and I had find by pet by ID operation in there. So I can just do it so simple, right? So Bravado actually used the fact that I defined something that is not necessary for a Swagger API. I defined the operation ID, find pet by ID. So then I can just call the client, so simple. The only thing I need to have, I need to make the Swagger file publicly accessible, the ground truth, the source Swagger file, the one that is used. And well, what you get for free is actually this client, the Bravado, will check if all your calls are correct, if they match the Swagger API, if the models, the parameters you pass have correct types, and it's going to be the same with return value. So if you call a microservices that had an API change, and it's no longer returning a pet that is ID, name, and tag, but it's returning a pet that is ID, name, and tag, and age, then it's going to show an exception. Okay. And so we've got the client thing solved quite nicely. And there is another thing that we can think if you could design the server in a similar way. We don't want to have so much boilerplate. We just can assume that we've got some single point where we have the API for each Swagger file, for each microservice, and we've got the connection library. Let me show it to you. It's going to be a demo. So I'm going back to my Swagger editor, and I can generate server. So the connection is actually default server promoted by Swagger. Where is it? Python Flask. Okay, so it generated the code. I have already opened it, and this is the main file. So it's quite, if you know Flask, this one is very similar. Actually, what was generated looks like this. So we've got two directories, controllers and Swagger. Probably the Swagger directory have the Swagger file. That's true. We have some license readme and so on. We've got the app. Oh, and the app is just as simple as a Flask app can be. So you create a connection app that is a wrapper on top of Flask app. Oh, you don't even have to do this if you just use the default arguments. You add the API that is defined in the YAML file. I didn't provide a description in the YAML file, so it's not generated. And you just run the app. So simple. Okay, but so where is the endpoint? How do you code the endpoint? And there is controllers directory, default controllers, and find pet by ID. That gets ID, you can fill the code and return some magic or do whatever you want. You don't have to define the models. You've got the IP in a single Swagger YAML file, and yeah, simple as that. We can try if this runs. Something is running. Okay, so what I can open is, I know that API is my base path. What Connexion gives you for free is the UI. So I open the UI, I see that I've got here a Petstone microservice that has a default controller with a single get endpoint to pets, gets an ID in path. There is all the documentation I had in my YAML file. It's generated on the fly from the YAML file. And even I can try this endpoint. I can get pet byte ID 25 and get, response to some magic, right? What if I write a string here? Whoa, something is wrong, but that's quite correct. I got it. Oh, sorry. Okay, I will show you the trace back because it's not good on the screen. But basically, what Connexion just done, it's you have no validation. That is always a pain because every endpoint in your microservice starts with a validation of parameters. You hate it, and then it calls, for example, some other microservice. That's a part of pain you have gone. Okay, so I've just shown you the editor. Generated the code with a single click. I showed you the Swagger file. I didn't, but it's the same. I showed you how easy it is to launch the app, and I see it just gave you a single function get pet by ID, which was not annotated or any other stuff, just the pure logic of your application. I also show you the UI, you've seen it. So I like it because it's very API oriented. It's also, you get validation for free, UI free, and boilerplate free. Okay, I've got some, to conclude the talk, I want you to remember 3 pictures. The first one is the wind turbine. That's the metaphor of microservices. The second one is the small ship in the storm. It's going to be tough. There are lots of problems with asynchronous communication, logging, with tracing transactions, with data that is not shared but is very distributed. So we've got distributed database. But you also have some tools that right now are quite good and that they will help you. And this is the drills picture. Okay, I guess that's all. If you'd like to contact me or ask some questions or your thoughts are different, you can tweet me or ask me here or on Slido. We've got some questions already. Oh, you're voting for them. Okay.
Yeah, we have several questions, so we would read. We have just a few minutes, so we are going to read them all, but the ones that got most likes. And the first one is, how do you prevent ended up having lots of microservices that have complex dependencies among them?
Okay, so you shouldn't be afraid of the number of microservices. That's quite natural. And when you go to microservices world, you know that all the dependencies are in the API. So these dependencies are not that painful, okay? And so yeah, you try to prevent it. So there are concepts that your microservices should be organized in a tree. So there are layers of which microservice could call which, but we don't use it. Yeah, we think if all the dependencies are API, it's not that hard to manage them. Okay.
Okay, so the second question is, do you maintain an older API versions? I imagine that API customers have different development cycle than microservices, so how do you manage the API versioning?
Yeah, so we try to make the time you maintain two versions of an API very limited. So usually it's okay for us if there is a microservice, we just and we make some changes to the API. We make it so that consumers can work on both versions of the producer, and yeah, it's for now it works for us. We know that it's not going to last forever, but till now we didn't solve it.
All right, so this one is maybe like your opinion. So is the monochromatic architecture obsolete now, or does it make sense for some projects?
You remember the enthusiasm graph? Actually, I think till 3 months ago, we all regretted the move to microservices. Yeah, and we regretted it heavily because in monoliths, many things are much easier. So probably it's no. I think there are use cases that monolithic application is much better. If you have a lot of asynchronous communication, like your system calls and other systems, like we do with mails, APIs, for example, Google Mail, we also integrate with Salesforce. Then you've got some asynchronous communication that can be very painful in monolithic applications because you can have threads hanging. You don't want to have this.
Okay, I think we will have the last question, and the rest will from you.
Okay, so
you can answer the blog or whatever. So the last question would be: on which infrastructure are your microservices running? Virtual machines, Docker? Do they scale automatically?
We use Google Cloud. We use Docker. They don't scale automatically, but we hope to have it one day. Actually, scaling automatically is not that easy, and we observe that for now, it's enough if we can scale them manually but fastly. So if we have to add these microservices 3 instances, if we can make it in 5 minutes manually, that's okay for now, for us. And there is another question I see about tests for Swagger API. And actually, there are a bunch of projects around this. There is a project called Swagger Stab. There is also, we have already in Browwatch 2 attempts to do this. And there is also Marek who is working on this. You can ask me or Marek. And there was also a talk on PyVal group last week, so maybe there is someone who was there and who knows a bit more. Yeah, feel free to talk with us.
Okay, thank you very much for your talk.